Okay, this is 6.3 homework help. The first problem gives us an ellipse right here. And it says it can be drawn with parametric equations if we let x vary with some number r times the cosine of t, and then y is going to have to vary with something as well, because how parametric equations work is you have x varying with a variable t, and you have y varying with the same variable t, and that makes up the ordered pairs of your function. So it wants to know what r is for this case right here for x, and then what y is. So right here, this r, if we graph this ellipse, now you might remember this from Algebra 2, hopefully you do, that the bigger number is a in an ellipse, which is the semi-major axis, and that's 5 in this case. So if that's underneath y, then it's vertical. So we go up 1, 2, 3, 4, 5, we go down 1, 2, 3, 4, 5. This thing's centered at the origin. And we go over 2 for the semi-major axis, so that's along the y-axis here. The ellipse looks like this. That's really bad. All right, it looks something like this. Now, you might not remember how to graph this, in which case there's an app on the calculator I can show you that does that. Or on our formula sheet, I have information about parabolas. We don't cover it till Chapter 8, but you did cover this in Algebra 2. We're talking about ellipses, and we're looking at this column because A is underneath Y. So that means that the focal axis is x equals 0 in this case, because h is 0, which is the y-axis for the focal axis. So it opens vertical, and all the information's here as far as the foci, the vertices, the semi-major axis. All the information you need is in this table. So you can actually use that, and if you want to know more about that, I'll show you that. But basically, we graph it like this then, where the focal axis is x equals 0, goes through the two foci, and it's a vertical ellipse. So what we want is we want x, we want to know x varies as some number times the cosine of t. Now the cosine we know fluctuates from -1 to 1, but we need this thing to fluctuate from -2 to 2. So obviously we want r to be 2. So that we, just your x value, I know I'm just graphing the x value, is going to fluctuate then from -2 to 2, which is exactly what we want right here. Now y is going to have to vary as well. Now y goes from -5 to 5, so we want to use 5 as our amplitude, and we want to either use cosine or sine. We need to figure out which one, because obviously these are periodic functions that fluctuate, from -1 to 1. When we multiply by 5, we'll fluctuate from -5 to 5, which is what we want. But we have to figure out which one to use. And it turns out the answer is sine, 5 sine of t. And the reason why is because we need to look at this point right here where we start. Now at this point we can make a table for t, x, and y. And what we find is that, we start with t equals 0, because we're rotating by no angle right here. Start off with t equals 0. At that point, we know when we plug in 0 for cosine, we get 1, cosine of 0 is 1, 1 times r2. In this case, x, this is equal to 2 cosine of t. So when you plug in 0, you get an x value of 2, which is what we want right here for this point. At this point, the y value is 0, so we need to get a 0. That's why we use sine. So we're going to use sine here. Because when we plug in 0, sine of 0 is 0, and we need to get 0 for y, which is what we get. So just make sure that this starting point matches up with both the functions, and then you'll see that that would be our answer here. All right, the next problem then wants us to match these parametric functions with their graphs. Now, you can do this by hand without a calculator if you wanted, and it's actually really good practice, because what you do is you make a table kind of like we did last time, where you start off with t equals 0 and find out what your x and y ordered pair are, and then use other points. Start increasing time here, or the t variable, and you'll find different order pair, and you can match those order pair with a specific function. Now we're going to cheat. We're going to use the calculator. I am going to allow you to use the calculator on the test for these type of problems. So what you want to do is, in your calculator, you want to go to mode, and you want to change your calculator to parametric mode, which you want to scroll down and scroll over, hit enter. And now we can go to y equals, so get out of there, go to y equals, and you'll notice a completely different y equals. You'll notice x varies with time, y varies with time. So you're going to plug in those equations there. Now when you plug these in, you hit the variable button right here for x, t will show up, and that's what you want. Now when you go to graph this, you're going to have to change your window first. So I went from -200 to 200 for my t values. And I changed my t step to 5 because you don't want this too small, otherwise it's going to graph too many points, and it's going to take the calculator too long to figure out all these points. And then I went from -8 to 8 for both x and y, because that's the window that I saw from the graph on Webwork. Right here, for example, you'll notice it goes from -8 to 8. So then if I go ahead and graph that, it's going to take a little while, but it'll graph this, and then you can compare and say, okay, well that's D. And then just do the same thing for the rest of them. So go back to y equals and type in the next function for both x and y that vary for x and y. Like this one here. Now for this one I have a weird graph right here which doesn't match any of them as far as I can tell. So what I'm going to do is look at actually this graph and say, hey, wait a minute, this graph has a different window. It goes from -10 to 50. So let me see if I can change that and get it to maybe look like this one. So I go from -10 to 50, and now take a look at that. And that doesn't look like it, but it looks like it could be. What's happening is my t in this one, I'm going by 5, so I'm going to try to go by a smaller number here. I'll try to go by 0.5. I know it's going to take longer to graph, but let me see if that changes the way it looks at all when I graph more points. And I'm having some problems with this one. I keep getting what looks like a parabola no matter what I do to my window. So I don't see that one anywhere on here, so I'm going to skip this one for now and head to number 3. Now I'm trying to graph the second one here, and it's taking too long because my window, my t-step's going by too small. So I'm going to have to change that back. Alright, now when you do that, you get what looks to be E, this last one here. So we have E. Now I'm going to do 4, and that gave me A. 5 gave me B, which means that 2 should have been C. I'm not sure what was going on with 2 with this graph, but I couldn't get it to look like that. And I figured it out actually. My calculator was in degree mode and I needed it in radian mode. So go to radian mode and then we can take a look at that same graph, and you will see what we were supposed to get there. Alright, the next problem says we want parametric equations for a line segment between these 2 points, and they give us some information that's really helpful. They give us this piece of information here and this piece of information here that we're going to use with these lines. So we know x has to vary as a plus bt, and they tell us when t is 0. So if I plug in 0 for t, and x is 3 at that point, so if I plug in 3 for x, that'll help me find a, and a will be 3 in that case. So I know a is 3. So I can now write x equals 3 plus bt. I can do the same thing for y. If I write down the y equation right here, and then use this piece of information here, which is when t is, use the same piece of information here when t is 0, I get y is -10. So what that tells me is c is -10. So I have c, and I can write that here. Now I can use the second piece of information with these new equations that I have. So when t is 1, so I'm going to take x and plug in t of 1, and I don't need to write that then. And then x at that point is 2, so I can plug in 2 for x, subtract 3 from both sides, and find out that b is -1. So now I know b is -1, and I can do the same thing with y. Go ahead and plug in 1 for t there, and it says y is -5 in that case, so plug in -5 for y, and then solve for d. Add 10 to both sides, you get d is 5. So there's what we're looking for our parametrics. If you graph these in your calculator in parametric mode, you will get a line segment that goes from -3, 10, or 3, -10, and 2, -5. Okay, so for the next problem, we want to eliminate a parameter t, get this this parametric equation and function notation here, our regular function mode. So what we're going to do is solve one of these equations for t and substitute it into the other one. So I'm going to add 1 to both sides for this top equation, and I get this, and then multiply through by a -1. And now I'll substitute that t in right here. So I have y equals -19 minus 3 times this t. And now there's my function. I'm going to put it in y equals mx plus b form, so I'm going to simplify this by distributing a -3 in both terms. Plus 3x plus 3, y equals then 3x minus 16. So I'm looking for a slope of 3